Alright, so here's an example. We're given a position versus time graph, and we have a velocity versus time graph. So we need to translate this graph into this graph. So here's how it's going to work. First, what we need to do is we need to find our velocities. Okay? And we know our velocity is equal to slope. So we need to find our slope for each segment on our graph. Okay? So I'm going to number these segments for us. Let's put those in blue. So we're going to do segment 1, segment 2, 3, and 4. Hey, this won't be too bad. It should be nice and easy. So let's do segment 1 first. Segment 1 starts at position 3 and moves to position 2 in 2 seconds. Notice it looks kind of short. It looks like it's 1. I kind of skipped 1 here. But no, it's 2. So it moves from 3 to 2 in 2 seconds. So let's write that out. So our slope then for number 1, velocity 1 is going to be equal to, we have delta x over delta t. Okay, so our change in x is going to be 3 minus 2. Okay, we went from 3 to 2, and actually I have that written incorrectly. We always need to put our where we ended minus where we started, right? Final minus initial. Okay, so right there, and we know we did that in 2 seconds, so that's going to give us negative 1 over 2. So we have a negative ½ units. Okay, that's where we start. So that's number 1. Let's find number 2. Number 2, I'm going to put number 2 up here at top. So number 2. So here we moved from 2 to 4 in 2 seconds. So we have 4 minus 2 over, and then C. So then 4 minus 2. So that's going to be 2 over 2, which is equal to 1. Okay, so our slope for our second set is 1. All right, number 3. Let's put number 3. We'll cram him in here. So number 3. Hey, so we're going from 4, and we haven't moved. So what's the slope automatically? And it's a flat line. We notice that it's a flat line. So we automatically know that 3 slope is 0. But we do need to know for how many seconds. So I'm going to write something that doesn't make like any sense, for 1 second. And the reason I write 1 second is because we go from second 4 to second 5. We traveled 1 second. Okay, that's very important. So let's look at number 4. I'm going to put 4 at the bottom here. It's kind of out of order, but just bear with me here. So number 4, so we moved from 4 meters to 0 meters in 1 second. 5 to 6, the difference there is 1 second. So let's write that out. So we moved from 0, that's our final, minus 4, all over 1, or that's really 6 minus 5. I'm just doing the math in my head. So that is going to be negative 4. Okay, awesome. So now we have all of our velocities. So we've got our negative 4, we've got our negative 1/2, we have 1, and we have 0. Okay, those are a little out of order, but we'll go with it. Alright, so here we go. This is what our graph looks like. So we've got our first part we got to graph is number 1. So we have negative 1/2. Alright, 1/2. That's what our velocity is. We're going to do that for 2 seconds. 2 seconds right there. So here it goes. So I take my line, and I've got a red line. I start at 1/2 and I go across. Okay? And I'm going to mark that. That's going to be 2 seconds. Okay? Notice negative 1/2 is not where I started. Okay? This is not where I started. I can't figure out where I started from a velocity versus time graph. So I lose that information as I move through this process. Okay, so that's just a little mental note. So our next one is going to be, we look at 2, right? 2, and that's 1. So we then immediately move up to 1. Okay, that's not our velocity. This vertical line is not our velocity. That's just us. It's a notation thing so that we can make it our line continuous. Okay, so in other words, so it doesn't have any breaks in it. Okay, so then I draw my line, and notice I only went for line 2 goes for 2 seconds, so this should be second 4. Okay, and I look at my next line. So my next line, alright, so I've got number 3, and that's 0. So what I need to do for that is I need to come back down to the time axis, so where the 0 is. Notice we've got 0 right here. And then I need to go over on the axis. That's supposed to be on the axis. And it's a little bit above, but that's supposed to be on the axis. And that's going to go for 1 second. So we'll put second 5 here, just for notation reasons. And then my final step is I bring my line all the way down to negative 4 and across. Okay, and I make a mark at the end saying, hey, that's second 6. Okay, and hey, would you look at that? I've got my velocity graph. That's how that example works. Alright, so here's one last example, and this one's, we want to go from a velocity versus time graph to a position versus time graph. In order to solve this problem, the first thing we need to do is we need to figure out the total displacement. The way we do that is with the area under the curve. Okay, we need to look at the area under the curve, okay? So, we have our velocity graph, so we need to divide this up into chunks. Let me erase some of these, those are bad chunks. Divide this up into chunks that we can take the area of. Okay, and then again, notice I am just going from the high points to the x-axis, or excuse me, the time axis. I'm going from our high point to the axis. Okay, I'm not adding any extra information. Okay, just in those areas. Let me put some blue dashes in here. Make it a little more obvious. Okay. So I've got these areas here. Let's break these down. Okay. This might get a little complex here, but let's just go for it. So if we look at our first block, let's number our blocks like we did last time. So this will be number 1, 2, 3, and 4. Okay. Number 1. So we need to find our height, and we need to find our height, and we need to find our width. Okay. Our width is going to be 1 second because we went to 1 tick mark, and there's 5 total tick marks. So 1 second. Okay, we went for 1 second. And how high are we? We are 2 meters per second high. Okay, so we know 1 is going to be 2 times 1, which is just 2. So that's our area for number 1. Okay, number 2. Block number 2. Okay, again, we only have 1 second here, but we have a little bit higher height this time. We're up to 3 already. So this one is just going to be 3 times 1, which is 3. Okay, alright. So we've got our blocks. Let me put those in there for you. So we got 2 here, we've got 3 there. Okay, number 3, again, very similar. Alright, we've got a width of 1 and a height of 1 right there. 1 right across. So we have 1 times 1, which is 1. Alright, so we're getting there. We've got 3 down. 1 more to go. 4 is the big one. Okay, so number 4 here. Alright, our width has increased. We have 2 seconds here to the 4th and to the 5th second, so we have that whole distance. Plus, now we have this distance below the axis. And it's very important we hang on to our negative sign, okay? So our height here is negative 4. Okay, while our time is 2. Very important to notice that. Okay, so number 4 is going to be negative 4, that's our height, I'm going to put that in parentheses so we know it's negative, times by our width, which is 2. So, looking at that, negative 4 times 2 is negative 8. Alright, we have all of our displacements. Alright, now there's a very important piece of information that we don't have yet to solve this problem. That's the initial position. Where did we start? Okay, we need to know where we start. And I will always give you what the initial position is, okay? And today I'm going to give you the initial position, and we're going to say we're going to start 2 meters. Okay? So I'm going to put my little red dot right there on 2 meters. Now, an easy way to figure out what our position graph looks like from our velocity graph is by looking at our displacements, our individual displacements, so our 2, our 3, our 1, and our negative 8, okay? These are the amount of distance we've moved, or length of distance we moved from the last point. So, with that said, what I can do is I can say, alright, in our first time frame, which was 1 second, I know that from our velocity graph, 1 second, I can say that from 2, I moved 2 more meters. So I'm going to go up 2 and over 1 second and put a dot. Okay, this is at, now this is 2 meters up, this is 2 meters up and 1 meter over, or 1 second over, okay? I do this again, and I say, hey, at 2, I move 3. Alright, so we'll move 3. So we'll go 1, 2, 3, and over 1. 1, 2, 3, and over 1. Okay, so I can see that, alright, I moved there. Alright, and so I put my dot in there. Next, I see, alright, so I gotta move one more up. So I'm gonna go over 1, moving a little bit off my chart, but hey, that's alright. We'll just say that's one more, so that would be like 8. Okay, and then finally, I move all the way down to 5. Okay, in 2 seconds, I move that far. Alright, and I know this because I went -8. Okay, I was at 0. I know I went -8. Alright, I know this because my total displacement, if I add all these up together, so if I say, so displacement, I'm going to abbreviate, and so then I would say 2 plus 3 plus 1 plus -8, I know that's equal to -2. So I know my final position needs to be closer to 0 than my previous position, or to negative. Alright. Also, I can count. I can say, alright, this is at 8, 3, and I know at 2 I need to go down 8. So I go 1, 2, 3, 4, 5, 6, 7, 8, and hey, would you look at that? I'm at 0. So I need to know at time 5 I need to be at 0. So then all it is I need to connect the dots. So I connect this dot with that dot with that dot, all the way down here to this dot, and voila, there's your position graph.